तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करने वाले हैं. Assume that the tunnel is dug along the chord of the earth at a perpendicular distance r by 2 from the earth's center, where r is the radius of the earth. All of the tunnel is frictionless. If the particle is released in this tunnel, it will execute the simple harmonic motion with a time period. So we have to find the time period of the simple harmonic motion. Okay. So what they have given is that if we put the particle in that tunnel that is made in a earth, that particle is gonna make the simple harmonic motion. So the equation of the simple harmonic motion is given by force is equal to minus kx. Here force F is the restoring force. Okay. So basically what we have to do is that we have to find this restoring force and then present in present it in this particular kind of format. Okay, minus kx, where x is the displacement of the particle from the equilibrium position. So equilibrium position of the particle is somewhere here at the center of the tunnel. So first of all, let us find the restoring force. So let us assume that this is the tunnel. Okay, and particle is over here. So restoring force will act either downward or upward direction. So vertical direction, the restoring force will be applied based upon the position of the particle. If the particle is over here, restoring force will be this way, and if particle is over here, restoring force will be in upward direction towards the mean. So this is the mean. Okay, so let us find the restoring force. Let us assume that particle is over here, and we have to find the restoring force which is direct towards the mean position. So how do we find that restoring force? So to do that, we know that this is the center of the earth, and we can easily find this force, right? Gravitational force on this particle because of the earth's gravity. So if this particle's mass is say m naught, okay, and earth's mass is, let us say, capital M, then gravitational force will be given by g, which is the gravitational constant m0, and capital M, earth's mass, divided by r cube, that is radius of the earth. We have to take the cube of that into distance r. So distance r is basically the distance between the center of the earth to that particle. So let us assume that it is r. Okay, so you can see that this force is acting like this one in this direction, like that. Okay, so we can split this particular factor in horizontal and vertical component. So we have to find this particular vertical component. So let us assume that this angle is theta. Okay, over here, this is the angle theta. Then cos theta will be vertical component of the force divided by original force. So vertical component of the force is gonna be F cos theta. So we have already calculated the force, so we will just put those values over here. G m naught capital M divided by R cube to R, and cos theta we have to find. So cos theta is basically, so this distance is gonna be x. Okay, let's assume that to be x divided by r. Okay, so r will cancel out, and so this vertical component of the force is basically a restoring force. Okay, if you talk about the simple harmonic motion, restoring force is gonna be g m naught capital M divided by r cube and x. So we know that the restoring force is basically in this format. So we can assume that this is particular thing is minus k, right? So we can write k is equal to gm0 capital M divided by r cube. We know that time period of the particle which is doing SHM is given by 2 pi under root of mk. So here m is m0 and k's value is this one, gm0 capital M r cube will go to upward. So it will be like this one is equal to 2 pi under root of r divided by gm divided by r square. So this one is basically a g. Okay, 2 pi under root of r divided by z. And that's the time period of the particle doing the simple harmonic motion in the tunnel.